Hello, dear friends. Myself, Sachin Misra, chemistry faculty. I have the experience of 8 years. I teach up to the level of JEE Mains, NEET, and above. Let's continue. We are going to continue today thermodynamics and about the process. Process. Today, topic we are going to discuss about process. Let's start. Now, what is the process? Process means we can say a path through which change in state of system occurs. Means we can say the path through which we can change in the state of the system. Means we can change the state of the system by any way that is called process. On the basis of classification, we can classify this process in following categories. First, isothermal process. What is isothermal process? Isothermal by name it's clear. Iso stands for same. Thermal stands for going for temperature. Means throughout the process, temperature is going to be constant. So we can say temperature is going to be constant. And since we have studied already for gaseous equation, PV equal to nRT. And since temperature constant, so whole factor become constant here. So we can say PV equal to constant and P equal to, I'm going to replace constant by K here, constant by volume. So here we got P, it's same like Y inversely proportional to X curve. In mathematics you have studied Y inversely proportional to X curve is like this. This is your Y and X. So PV curve we can draw same like this. This is P versus V curve. I hope everyone okay. Now in differential form, we can further modify this equation in differential form also. How? Can I write like this? PV equal to constant. Let's do differentiation. So you have studied in mathematics differentiation of first into second function. So we can write first into second differentiation plus second into first differentiation. And the differentiation of constant equal to 0 as you have already studied in mathematics. So we can further write here P into dV equal to minus V into dP. Let's simplify. We got dP by dV equal to minus P by V. This is our final relation for isothermal curve. Sorry, not curve. Isothermal process. Because we are going to discuss about the process. So here we can say for isothermal process, PV curve will be like 1 by Y inversely proportional to 1 by X curve. In differential form, we can write P into V equal to constant. So P dV plus V dP equal to 0. So we got dP by dV equal to minus P by V. So this is our one relation. I hope up to this everyone okay. Let's move to the next process. Our next process is here isobaric process. Isobaric stands for iso for similar, baric we going to discuss about pressure. Means pressure is going to be constant. And according to the gaseous equation PV equal to nRT, since here pressure is constant, nR we assume here constant, so V proportional to T. If we either we can write V equal to KT. It's similar to Y equal to mx curve. And this curve will be like this straight line passes through the origin. And in differential form, we can further write V equal to KT. Let's differentiate here. dV equal to dV by dt equal to K. We can write like this. V by T equal to K. We got A by B differentiation. We can write here T into dV. In mathematics, you have studied here differentiation of A by B minus V into dt upon T square equal to differentiation of constant, already it is 0. So we can further modify cross multiply. So we got here TV equal to V dt. Let's simplify this. We got dV by dt equal to V by T. This is our relation, differential form of isobaric process. I hope up to this everyone okay. Okay, let's move to next concept. That is our isochloric process. As we have discussed, isothermal, isobaric. Isothermal stands for pressure going to be constant. Isobaric stands for pressure going to be constant. Now next process is isochoric. Isochoric means volume is going to be constant. So let's discuss about isochoric process. Isochoric process means volume will be constant here. Since volume is constant, so further we can write PV equal to nRT. nR we assume constant here. Since isochoric, so volume also constant. So we got beta P proportional to T. Either we can write here P equal to K into T. Let further we can modify like this. P by T equal to constant. If you want to draw curve here, so we can draw P versus T curve, straight line passes through the origin. Okay, if you want to write differential form, so we can write T into Tp minus P into Tt by T square, as you have studied in mathematics how to differentiate A by B. This is further equal to constant. Let's simplify. T dP minus P tt equal to 0. I hope up to this everyone okay. PV equal to nRT. Volume is constant, nR is constant, so P proportional to T. Since P equal to KT type pattern is there, so it will be straight line passes through the origin. And P by T equal to constant, so let's differentiate. We got T dP minus P dt equal to 0. And further simplify, we got Tp by dt equal to P by T. This is our differential form for isochoric process. And now let's proceed for next process, that is our adiabatic process. So let's see, let's move to the next concept. I hope up to this everyone okay. Let's see next. Next is our adiabatic process. Adiabatic process is what we can say. Adiabatic process means heat is overall that Q equal to 0. Heat exchange will be 0. Means there will be no exchange of the heat. And for adiabatic, as we discussed previously, it follows the for gamma equal to constant. Let's continue here. Adiabatic process follow PV power gamma equal to constant equation. So we can further simplify this. Let further differentiate, and here gamma, Poisson's ratio we can say. So let's continue here. We can write further differentiate first into second and plus second into first like that. So first into d by, yeah, let's write direct here. You have, as you already studied in mathematics. So I'm going to write direct here. So let's see. It will be P into gamma V power gamma minus 1 dV plus V dP equal to 0. First into second plus second into first. So let's simplify. We can write here P gamma P V power gamma minus 1 and dV equal to minus V into dP. We can further write gamma into P into V inverse into dV equal to minus V dP. We cancel out. We can further modify dP by dV equal to minus gamma P by V. So you can observe, Hannah, you can see this equation. It's similar to the isothermal. Only one difference, it is gamma times more than this. So Hannah, this is the dP by dV. It is for adiabatic. And as we have discussed previously, if you remember, for isothermal process, we got dP by dV for isothermal beta. It is your minus P by V. So by equation number 1 and 2, we can observe adiabatic curve is gamma times more than the isothermal curve. I hope everyone okay. Means we can say slope of the adiabatic and a PV curve slope of adiabatic will gamma times more than the isothermal curve. Clear? So let's move to next concept. We can discuss about some curve also. We can discuss one problem. Let's see one problem. If I give you problem like this, we have to find out which type of curve available here. So one simple trick we can follow here, curve like this. This is your PV curve. You can see this curve number 1, curve number 2, curve number 3 and curve number 4. You can see curve number 1 have the pressure constant throughout the process. I can see curve 1 is isobaric and curve 4 you can observe here volume is constant throughout the process. I can say it is isochoric. And see the 2 and 3. Here is the maybe some confusion to find out a total rate. So one simple trick you can follow here. One simple trick you will So one simple trick we can follow. What is that? So simple you trick, remember, you put your thumb here and rotate your finger like this. The first curve, what it cut, it will be your isothermal. And the last one will be your adiabatic curve. So simple. Where the center of this two curve is there, rotate your finger. First will be isothermal and last will be adiabatic. So I hope everyone okay. Let's move to discuss for the next concept. Either one more problem we can try here. Let's see one more problem. If I give you this one curve like this, we have three curves and all three are isothermal. This is PV curve and all are isothermal curve. Isothermal. If I say assume for this curve temperature T1, for this one T2, for this one T3. If I ask which one have which temperature is more, T1, T2 or T3, arrange this one increasing order of temperature. So let's try how we solve this problem. See better. Simple problem. If they given curve like this, so first you draw a perpendicular line either on x-axis or y-axis. You can choose anyone, no problem. So I draw a perpendicular line on x-axis. That means I assume volume is constant. Perpendicular on volume, that's mean volume is constant. If I draw perpendicular on pressure, so I assume pressure is constant. So if I draw the line, so we observe for curve T1 and curve T2 and for curve T3. This is this height called here P1, second height called beta P2 and third height called here P3. Simple, we know PV equal to nRT. Since we assume volume constant, are already constant, so P proportional to T. So we can say indirectly, more pressure means more temperature. If you see carefully this curve, so we got P3 more than P2 more than P1. So I can say T3 more than T2 more than T1. I hope everyone okay with this process. Sorry, with this problem. Let's discuss types of thermodynamics process on the basis of reversible. We are going to mainly discuss here reversible and irreversible process. Up to this, everyone okay? Let's move to next concept. Next concept is here reversible and irreversible. In reversible, irreversible, main problem is student what face. Generally, for irreversible process, pressure we assume constant throughout the process, and reversible process pressure is variable. So generally, student get in y constant, y variable here. So let's first discuss what is reversible, what is irreversible, and why we take pressure constant in one case, and in one case why we take variable. So let's discuss better. So first, what is the meaning of reversible and what is the meaning of irreversible? Let me simple example. Assume a cycle pump you have seen. If you have seen a cycle pump, that's like this. Here one pipe is there like that. By the help of that, and now in modern time we have the no need of this. But in old time we use like this. If you remember. So when we press now, suddenly we press. Once we handle upside, then suddenly we press and we got some air enter to our cycle tube. Okay. Now let's see here. During this process, this is your irreversible process because we done this whole work in a single time. It is your irreversible process. So irreversible process during this pressure become constant throughout the process. From the first point to the last point, pressure will be constant. But one example of this is your irreversible process. For reversible process, one best example I'm going to give you. Listen, assume we have a container and in this container we put a piston and here is some gas. So initially assume piston is frictionless, nothing friction, everything available. So what will happen better? Assume now if I don't apply any external pressure, friction, everything zero, nothing. Assume ideal situation. So what will happen? From upside atmosphere apply pressure from inside, gas apply pressure. So common sense is there. If piston is stopped here without any external force, that's mean pressure inside this container is 1 atm, because pressure from outside equal to pressure from inside. This is in equilibrium position. So pressure from outside equal to inside. Outside is atmosphere. So pressure equal to 1 atm. That's equal to pressure of gas. Assume I put now. Assume here. So we can say here initially pressure of gas equal to 1 atm. Assume I put one particle of the dust. One small particle of dust. So common sense is there. Dust has the negligible mass. But if something mass is there now, if mass is there, beta, so piston will slightly move downside. Very negligible movement will be there. We unable to observe that, but there will be movement. We unable to see properly what is the proper movement is there. But in reality, there is movement. So if I add a small particle, so common sense is there. Assume it move downside dx distance. If I add 2 particles, so it will move 2 dx distance. If I add 10 particles, so it will move 10 dx distance. When I add the first particle, so initial pressure was 1. When I add first particle, piston goes slightly downside, slight pressure increase, because initially pressure was due to only atmosphere. Now finally pressure is due to atmosphere plus dust particle. So mass will increase, so slightly pressure increase. So initial pressure was 1 atm, now become 1 plus dp. When I add the second dust particle here, it becomes further dp. Third dust particle, further dp. So we can say if I want to move piston from here to here, so it will take infinite steps. Assume I move up to this process up to infinite steps. So in every step, dp pressure going to increase. We can say pressure is here variable. I hope everyone okay. Why in reversible process we take pressure reversible? Pressure is constant. Variable, what we can say here? We can say beta at every, when I add the first dust particle, so piston slightly move, negligible movement toward downside, but again stop. Means can you see with naked eye? No, it is not possible. If we try to see with naked eye, we cannot see that. So indirectly we can say there is no movement in the, and equilibrium means what? Reversible means what? Reversible means equal movement in forward and backward direction. 100% reversible, it is not possible, but we can go up to reach that. We can reach up to that. If anyhow we make the movement of the piston negligibly 10 to 0, we can say 10 to 0 movement is there. So we can say that is reversible process. So you can feel if I add one dust particle, so piston has the negligible movement. If negligible movement, so that is in reversible situation. That is in equilibrium. We can say that is reversible process. So I hope everyone okay. Irreversible, sudden movement is there, so pressure is constant. Reversible, every step have the, and in irreversible you observe when I put the piston pressure, suddenly move here to there. During this whole process, pressure become constant. But in reversible, I add one dust particle. So after every step, pressure becomes dp increase. So pressure becomes overall variable. I hope up to this okay. Let's find out what for reversible and irreversible. W equal to minus P dV. Either we can write here W equal to minus P external into dV. Since here pressure is constant, so no problem, our work will be PdV. And here assume initial volume is V1, final volume is V2. So I can write W equal to minus P external V2 minus V1. Work done, calculation for irreversible process. Now let's discuss about the work done calculation for reversible process. How we can calculate work done for reversible process. Now let's discuss here work done calculation for reversible process. Since beta, as we have discussed, during the reversible process, pressure is your variable. Since pressure is variable and we have studied W equal to minus P external dV and volume move from V1 to V2. Assume piston initial volume is V1 and final volume become V2. V1 to V2. So since here pressure is variable and volume both variable. So according to mathematics, when we do integration, there should be only a single variable, but here is two variables. So I can write here W equal to minus P external V1 to V2 dV. Let's see beta. We can further write here. We know PV equal to nRT. Since pressure is variable, So here pressure volume both variable. So in integration we have to remove one variable. Anyhow we have to convert into a single variable. So can I write P equal to nRT by V? So replace here. We got P V1 to V2 nRT dV by V. This is the work done calculation for reversible isothermal. Mentioned in the previous case also. Work done calculation for irreversible isothermal, and this is the for reversible isothermal. Work done for reversible isothermal process. Reversible isothermal process. Previous was also isothermal. Note down this. So let's see here. I can write here minus nRT, temperature is constant beta here. So V1 to V2 dV by V, to integration we got minus nRT ln V2 by V1. Either we can write further W equal to minus 2.303 nRT log V2 by V1. I hope everyone okay with the work done calculation. Okay, for today it's enough. Now we'll meet in next lecture.